languages have always fascinated me. And when something new comes along, you know, where you go, oh, that sounds like an interesting problem. And this really sounded like an interesting problem. So I decided to get myself involved in it. And at the time also, I had been doing C# for over a decade. And I was actually sort of angling to get my hands dirty more than I was. I didn't write code on the C# compiler itself. I wrote a bunch of code in the early .NET framework and Link and some of those technologies. But for C#, it was more about writing specs. And there was something missing, you know, like what got me started in this to begin with, like early, was writing code. And I wanted to get back to writing some code too. So there was an opportunity to do that too. And I just needed something different too. This seemed like a fascinating problem to go work on. But in the beginning, I was really just helping them with the design. Steve built the first prototype compiler, the 08 compiler, out of the parser in Chakra. And then added an emitter to it. It was all written in C and cobbled together in a hurry. But we worked together on the design of the type system, the very early beginnings of the type system, right? And then eventually we decided, okay, there's a there, and we're gonna go build a real compiler. And that was the 09 series of compilers where we recruited some folks. Some came from the C# compiler team, actually. And we built, in retrospect, what ended up being sort of a C#-like compiler, but built in the early TypeScript, but it had lots of classes and lots of auto-generated code. You know, before we even got started, we had auto-generated classes for the parser, you know, like to the tune of 25,000 lines and whatever. And it kind of got a bit big and a bit unwieldy. But it was nonetheless ended up being the base of our product, the one that we initially released in 2012. But we also knew that maybe we're not quite writing this compiler the right way. It was very object-oriented and sort of very abstracted. Had lots of you know, interfaces that represented the classes that implemented the interface, like classic like Java or C# style of coding, right? But there's this other school of JavaScript coding that's much more functional, where you use functions nested within functions that do closure over the local state of the outer functions, and that's how you get privacy and isolation. And it turns out it's also how you get a lot more efficiency out of JavaScript quite often. So in order to teach myself about that style of coding, I started writing just for fun. Like, I'm gonna write a parser and see a scanner and a parser, and what's it like? And oh my God, it was like 5 times smaller and ran 5 times faster. And I go, okay, well, I guess I'm gonna keep going here. And then eventually implemented a type checker in that same fashion. And that's the code base we're on now. And we switched to that with the 1.1, I think it was 1.1, yeah. And, but even that journey took, you know, a year in the beginning of the project, but we're still on that same code base. And it served us well. It's a good paradigm. The TypeScript compiler internally is very much an exercise in functional programming. Our parse trees are all considered immutable, and the type checker is a single function that creates a type checker, and all the state is contained in that single function. It has 1,000 smaller functions inside the outer function, but it's one big thing. You know, and so you can ask for an instance of a type checker, and when you're done with it, you just let go of it, and it all disappears again. And you can have multiple type checkers on a single syntax tree and whatever. And it's a nifty architecture. And it turns out that when you write a compiler with knowing that this compiler is also going to be the engine that powers tooling, you have to write it very differently than if you're just writing a classic command line style compiler that can have multiple passes and blah, 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 blah. That's not going to work when you're sitting in a 100,000 line code base and user is typing and now types dot and needs an answer within 200 milliseconds of what are the possible methods on this object. You can't compile the 100,000 lines of code to figure out what what's valid here. You need a whole different architecture that's much more lazy and much snappier and much more minimal in just analyzing just enough to deliver that answer, right? And that's it's a very different way of writing code or writing compilers. It's fun, and that's how our compiler is written.